Dear students, in the previous class we discussed about in the solutions we have discussed about what is meant by solute, solvent and the binary solutions and types of solutions we are discussed in the previous class. In this class we are going to be discussing about expressing the concentration of the solution. Expressing the concentration of the solution. Now before going to this, we should know what is meant by concentration of the solution. The concentration of the solution means the amount of solute. That is the amount of solute dissolved in known amount of solvent. Known amount of solvent. Known amount of solvent. This we call as the concentration of the solution. The concentration of the solution can be expressed by using the molarity, mole fraction, mass percentage, volume percentage, mass by volume percentage. By using these terms, we are going to be expressing the concentration of the solution. Yes, we will study one by one now. That is the molarity. First, we are going to be discussing about the molarity. Molarity means number of moles of solute is dissolved in 1 liter of solution. In 1 liter of solution, that we called as a molarity. That is the number of moles of the solute dissolved in the 1 liter of the solution. This can be defined as number of moles of solute dissolved in 1 liter of solution, that we call as a molarity. This is going to be expressed by using the SI of this is mole per liter. Mole per liter. Otherwise, we are going to be using the capital M. Capital M. The formula which is used to find the molarity is equal to, that is the molarity is equal to number of moles of solute divided by volume of the solution, in liters. This is the formula used to find the molarity of the substance. Then the next we are going to be discussing about the molarity. What is meant by molarity? Molarity is nothing but number of moles of solute. Number of moles of solute dissolved in 1 kg of solution. 1 kg of solution. This we call as a molarity. Now that is the number of moles of solute per kilogram. That is per kilogram of the solution. We are going to be expressed by using the molarity. This is going to be expressed by using the symbol, that is the mole per kg. Mole per kg. Otherwise, small letter. That is the small letter, that is M. We are using this to express the molarity. This is expressed to molarity. This is about the molarity. The next we are going to be discussing about the mole fraction. The mole fraction we are going to be discussing about the mole fraction. In this mole fraction, this is another method of expressing mole fraction is the another method which is used to the expressing the concentration of the solution. In this, for example, if you are going to be taken that example for the mole, before going to the mole fraction, we discuss about some examples for the molarity and molality. That is, for the molarity, I said that mole per liter. Suppose if you are going to be taken that 1 mole of NaOH, 1 molarity of NaOH means the 1 mole of NaOH means that is it can be expressed. 1 mole of NaOH means that is 1 mole of NaOH dissolved in 1 liter of water. That we call as a 1 molar NaOH. That we call as a 1 molar NaOH. Like that only 1 molar, that is a small m, KCl means that is 1 mole of KCl dissolved in 1 kg of water. 1 kg of water. That we call as a 1 molar KCl. Now we are going to be discussing about the next term, that is mole fraction. We are going to be discussing about the mole fraction. Now we are going to be discussing about the mole fraction. The mole fraction, it can be defined as ratio of the number of moles of the given component, to the total number of moles of the all the components present in the solution. All the components present in the solution is called as a mole fraction. That is the mole fraction of a component is equal to, this can be expressed as, that is mole fraction of a component is equal to number of moles of the component, of given component divided by total number of moles of the all the components. This about the mole fraction. For example, if you are going to be taken the example, for this, suppose a solution, that is suppose if your Na, Nb, Nc are the number of moles, that is number of moles of the component A, B, C present in a solution. That is suppose Na, Nb and Nc are the number of moles of a components A, B and C respectively. If you need to find the mole fraction of component A at that time, that is that it can be written as, that is this chi, representation of that is mole fraction by using the chi. This is equal to what the formula given, that is number of moles of the given component, means we should find the component A, number of moles of the component A, that is Na divided by total number of components, all the components, that is the A, Na plus Nb plus Nc. This about the, that is the mole fraction of the component A. Like that only we will take the mole components of the B, that is Nb divided by Na plus Nb plus Nc. Like that only we will take that chi C is equal to, that is components, mole fraction of the component C. If you are going to take that N, C is equal to Na plus Nb plus Nc. Then by using this is about the mole fraction of the component A, component B, component C. Here chi A, chi B, chi C are these are the mole fractions. That is the mole fractions of the component A, component B, component C respectively. If suppose we need the generally, that is the number of the mole fraction, this we are going to be represented by the number of components. In general, the solution containing the I number of components. At that time, we are going to represent by, that is chi. That is chi. I is equal to, that is if the suppose we need to find the component I up to I means we are going to be taken that Na plus Nb plus dot 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 up to Ni. Then that is we are going to be written this N. Then summation of we are going to be taken that is there is mole fraction of, that is I is equal to Ni divided by summation of Ni. This is about the mole fraction. The mole fraction of the given component we can be finding by using this. The next we are going to be discussing about the mass percentage. Next term we are going to be discussing, that is a mole fraction means, once again I will explain what is meant by mole fraction. The mole fraction is the ratio of the number of moles of the given component to the total number of moles of the all the components. Total number of moles of all the components. Suppose example I took here, that is Na, Nb, Nc are the number of moles of the components A, B, C respectively. If suppose we need to find the mole fraction of the component A, at that time I said that it is the ratio of the given component to the total number of components present in the solution. That is Na divided by Na plus Nb, Nc. Like that only mole fraction of the component B we can be written like this. Mole fraction of the component C we can be written like this. Then now we are going to be discussing about the next, that is the mass percentage. That is the mass percentage by using the mass percentage. That is mass percentage. Next we are going to be discussing about the mass percentage. Suppose the mass percentage of A is equal to, that is mass of component A, mass of component A into 100 divided by total mass of solution. Total mass of solution. This we call as a mass percentage. Mass percentage means its mass percentage of A can be calculated by using this formula. The mass of the component A into 100 divided by the total mass of the solution. Suppose if you are going to be taken some example for this, that is 10% of glucose in water means, what does it mean? 10% of glucose in water means, that is 10 gram of glucose and 90 gram of water. It results the 100 gram of solution. 100 gram of solution means this 10% of glucose in water. 10% of glucose in water means in that it is 10 gram of glucose is present in the 90 gram of the water. It means that is the 10 gram of glucose is present in the 90 gram of the water. Suppose another example, if you are going to be taken some other example, that is 70% of ethyl alcohol. Ethyl alcohol in means it does means 70 gram of ethyl alcohol and 30 gram of water. That's the reason 100% or 100 gram of solution. In 100 gram of solution, it's having the 70 gram of ethyl alcohol. That is the solution of ethyl alcohol means that is the glucose solution means glucose solution and glucose in water. Otherwise, we can call as a glucose solution. 10% of glucose solution means 10% is glucose is there in the solution. That means this about the mass percentage. The next we are going to be discussing about the volume percentage. In that volume percentage, like this only, the volume of the components A, volume of the component A, next we are going to be discussing about volume percentage of A. We can read it down. Volume of the component A, volume of component A into 100 divided by total mass of total volume of solution. Total volume of solution means the suppose it's example for this. If you are going to be taken an example for this, suppose anything you can take 10% of water solution or otherwise 10% of solution of ethyl alcohol. You are going to be taken the 10% of solution of ethyl alcohol. Ethyl alcohol. 10% solution of ethyl. It means that 10 ml of ethyl alcohol and 90 ml of water. It results in 100 ml of solution. Means the 10% of solution of ethyl alcohol means in the volume percentage when we express at 10 ml of ethyl alcohol and 90 ml of water, it results in 10 ml of solution. Means here the volume means we are going to be taken using the ml. The mass means we are going to be taken in the grams. Like that, you should be remember. This is about the that is volume percentage. The next we are going to be discussing about the mass by volume percentage. This by mass by volume percentage. This we can be defined as that is when a solute present in the traces quantities. That is suppose the solute is going to be present in the traces. That is it's going to be present in the traces quantities in a solution is commonly expressed by using that is ppm. That is ppm, parts per million. Then we are called as a parts per million. The parts per million means it's going to be taken. Parts per million means it is used the traces of solute present in the solution. That is at that time we are going to be expressing this by using this concentration of the solution expressing by this ppm. That is parts per million. In this number of parts of the component, ppm means number of parts of the component to the total number of parts of the all the components present in the solution. Total number of components, parts of components present in the solution. The parts per million. This we call it ppm means parts per million. That is the number of parts of the components. Number of parts of component names to the total number of parts, that is ppm means that is parts per million. So many times I have defined ppm, so many times asked in the examination. At that time it can be defined as, it is used to express the when the solute is present in the traces in the solution. At that time we are going to be use the, that is ppm. ppm means parts per million. This can be calculated by using this formula, that is number of parts of the components to the total number of parts of all components in solution. This is going to be used by using the ppm. ppm in parts per million can be calculated by using this. In this, you should be remember that the one thing, that is mass percentage, that is mass by volume percentage, then it is going to be mole fraction, molality. This and all is depends on, it is independent of the temperature, but the molarity is molarity is dependent on the temperature. Means the molarity is going to be decreases with the increase of the temperature. So many times asked in the examination, what happens when the molarity of the solution when it increases the temperature? Means it is going to be decreases, but others it is going to be independent. That is with this molarity only, it is a temperature dependent. It increases means then volume is going to be increases, temperature increases, volume is increases, the molarity is going to be decreases. This about the expressing the concentration of the solutions.